Engineering challenges of this scale require precision, innovation, and total commitment to safety. At Transdata, we take pride in delivering complex projects that redefine industry standards. Today, we present one of our most ambitious projects yet, the installation of the hot strip rougher and edger mills at the Gerdau plant located in Ouro Branco, Minas Gerais, Brazil. With its vast territory of over 8.5 million square kilometers and a population of more than 210 million people, Brazil stands out as the largest economy in South America and a key player on the global stage. Its abundance of natural resources and industrial diversity positions it as a leader in multiple sectors, with a strong emphasis on the steel industry. Gerdau is a Brazilian multinational, an enterprise in the steel sector, and one of the world's largest steel producers operating in multiple countries. In 2024, the company recorded a net revenue of $12.0 billion. Its Ouro Branco, MG State Brazil plant is one of the most advanced facilities in its portfolio, significantly contributing to the economy and society. It generates thousands of direct and indirect jobs and fosters regional development through infrastructure investments, professional training, and socio-environmental projects. The plant also stands out for adopting sustainable technologies such as scrap recycling and reduction of CO2 emissions, reinforcing Gerdau's commitment to sustainability and innovation in the steel industry. The installation of these new rolling mills will increase the plant's annual hot strip production by 33%, from approximately 4,500 tons to 6,500 tons per month, representing revenue growth in the hundreds of millions of dollars. Now, this project was not just about installation, though. It was about minimizing disruption in one of Gerdau's most advanced plants, where every hour of downtime translates into millions of dollars lost. The new rolling mills were installed within the operational steel production line, and our strategy was designed to minimize downtime, resulting in financial savings of approximately $96.5 million. It also became a milestone for Transdata, marking the largest movement ever performed with a 4-tower hydraulic gantry system in Latin America. Throughout the process, we provided our client with customized handling solutions during the assembly and installation of all main rolling mills components. The project began with the acceptance of the bold engineering outline concepts of these solutions. Our team was committed to finding innovative yet safe approaches, combining various types of equipment for heavy load handling. Gradually, all efforts have been converged to develop the most suitable solutions to meet all operational and safety criteria required by our client. This effort marked a major milestone for Transdata's engineering team, requiring so far the highest number of man-hours ever invested in a single project. The project was divided into 3 major phases. 1. Transport, lifting, verticalization, and the positioning of the rougher mill housings onto a temporary pre-assembling base. 2. Transport, unloading, rotor stator coupling, and positioning of fully assembled mill main motors onto their civil bases. 3. Lifting and final positioning of the rougher mill pre-assembly, the edger mill housing, and the edger mill gearbox support frame. Phase 1. Our first operational challenge focused on standing up and positioning of 2 515,000-pound rougher mill housings within a highly congested industrial area. Without halting the ongoing production, the internal transport rolled over meticulously planned and studied routes. One of the major challenges was maneuvering and positioning the components within an already operational production area without disrupting their manufacturing activities and coordinating alongside the continuous movements of rail cars carrying materials over its numerous track crossings along the route. High maneuverability, precision-controlled, self-propelled modular transporters, SPMTs, were successfully applied. Phase 2. Rotor stator coupling and mill main motors positioning. Key challenges included working within an extremely confined space with a 13.5-foot wide access path, managing the less than 1/4 inch clearance between rotor and stator during coupling, and mitigating the heavy lift operations load pressures on the existing concrete slab. Our remote-controlled SPMT and 500-ton capacity 4-tower hydraulic gantry, the modular slab shoring system, provided the successful combination that ensured the required precision, safe weight distribution, and control. Phase 3. Installation of the rougher mill pre-assembly, edger housing, and edger gearbox support frame. The rougher mill pre-assembly, the largest and heaviest component of this project, weighing over 1,675,500 pounds. Edger mill housing, weighing 750,000 pounds, and the edger gearbox support frame, which weighs 551,000 pounds. To execute these heavy and complex moves, our engineering team designed a combination of gantry towers, strand jacks, and optimized support structures to ensure time-saving, controlled, precise, and safe movements. This included a custom lifting beam developed in partnership with Primetals to handle loads evenly and prevent unintended structural stresses on the fully assembled mill. A high-set center of gravity, geometric limitations, and to avoid unnecessary building dismantling, overcoming very narrow tolerances. Then it was lifted and set onto its working position over its housing. The assembly of the edger gearbox was carried out in 2 distinct steps, ensuring maximum precision and safety throughout the process. In the first step, the base of the equipment was carefully transported and lifted using a gantry system, employing a specialized methodology to support its weight and ensure stability during the movement. In the second step, the assembly of the edger gearbox was executed using an innovative skid system, which allowed the unit to be moved to the exact lifting point. This process ensured that the equipment was positioned precisely, guaranteeing perfect integration at the final assembly location. 2,000 hours of planning, 2,920 hours of execution. Total investment, 4,920 hours. Transdata successfully completed the installation of the heavy and oversized components of the rougher and edger mills, part of the Steckel Mill Phase 2 project for Gerdau Açaminas in Ouro Branco. This project set records as the largest load movement using a 4-tower hydraulic gantry system in Latin America. It resulted in a 33% increase in hot strip steel production, minimized production downtime, and delivered a financial impact exceeding hundreds of millions of dollars. The success was driven by our safe and experienced operational force and our engineering team's expertise, meticulous planning, and commitment to safety, precision, and innovation. Transdata welcomes challenges that require engineered solutions that respond to specific clients' needs. Maneuvering large and heavy items within productive industrial realms has resulted in numerous outstanding interventions. Bring your project needs to Transdata